Good morning. Welcome back to the our IB stoichiometric lecture 5. Today we will see some of the concentration representing units. Mole fraction. One is mole fraction. Number 2, molarity. Number 3, molality. Number 4, normality. These are the common normal concentration units generally used in the stoichiometric equations or any chemistry, this thing. In particular, molarity and normality are very frequently used because they are very easy to convenient to use. Now, what is mole fraction? It is the ratio of number of moles of a particular component to the total number of moles in a solution. If A is dissolved in solution B, mole fraction of A equal to mole fraction of A equal to number of moles of A by total number of moles. That nothing but Na by Na plus Nb. That is the mole fraction of A. If I want mole fraction of B, is Nb by Na plus Nb. If any component is having 3, then Nc equal to like this. If 3 is there, also you can see. Then what is molarity? Molarity. Please carefully see. There are small differences, but a big calculation difference. Molarity. Molarity is number of moles of solute by volume in liters. Volume in liters. Solution. Solution. This is most important. Volume of the solution in liters. That is the molarity. Then if you see molality, top one is same, that is number of moles of solute is same. In the bottom here solution solvent mass in kg. Denominator change. Molarity and molality. Top one is same, number of moles of solute. Volume in liters, here solvent mass in kgs. That is volume in liters. Then what is normality? Normality is just molarity, normality is very nearer to each other. Here gram equivalent weight, number of gram GEW, gram equivalent weights of solute by same volume of solution in liters. Very simple. Tomorrow we will solve some of the problems. Now slightly bigger problem in stoichiometry will solve. Let us see this slightly bigger. So far we were calculating all problems in STP condition. If STP conditions were default, so how to solve the problem? We will see how to convert the volume and pressure if it is different. The question is, how much minimum volume of CO is required to completely react with oxygen, which is 0.112 liters at 1.5 atmosphere pressure and 127 degrees centigrade to give CO2. Normally we are calculating at STP conditions or NTP conditions. Here it is a different pressure and different temperature. The chemical reaction will, what is the chemical reaction? CO is reacting with oxygen CO2 is forming. Balance equation for easy comparison, CO plus half O2 gives CO2. This is a balanced stoichiometric equation. Now what was asked, how much CO is required to completely react with 0.112 liters of, this both are volume, but conditions are different. Now conditions we have to bring all the time to the STP. Now STP volume, CO we cannot change. STP volume of O2 is to be calculated. Temperature is 127 degrees, that is nothing but 127 degrees centigrade plus 273, 400 degrees Kelvin temperature. Pressure is 1.5 atmosphere. So simple formula, V1 V1 by T1 equal to P2 V2 by T2. P1 is 1, volume is to be known, T1 is 273, at STP what is the volume we are calculating, P2 is 1.5, volume is 0.112 liters at 400 degrees Kelvin. Okay, now V1 equal to how much, calculating 273 by 400 into 1.5 into 0.112. If you see at the calculation, the values will be around 0.115 liter. Because it is in liters, what we are getting. This is the volume of oxygen at STP. Whereas the volume whatever 112 is given is, that is at different pressure and temperature. Now, from the equation, half mole of oxygen is reacting with carbon monoxide gives to carbon dioxide. So half mole means it is 11.2 liters, because 22.4 liters is standard volume. Half mole of oxygen is required to react with carbon monoxide completely. Carbon monoxide volume is 22.4. CO volume is 22.4 liters. If oxygen volume is 11.2. But whereas our volume, whatever we have, the volume is 0.115 liters of oxygen. That means it is double to this. Nothing but 0.23 liters. Right? That is the answer, because it is just double. I think 22.4 by 11.2 into 0.115, nothing but 0.23 liters. So tomorrow we will see the normality, molarity, mole fraction problems. Okay, thank you.